Hello and good evening everyone. I welcome you all once again to this wonderful platform by Unacademy NEET English. Well, my dear lovely students, my name is Kar Khurshid Alam and you can also call me KK sir. My dear lovely students, I welcome you all once again to this wonderful platform and I believe that you all are doing good and having a great time. But before we move ahead, please let me know in the chats if I am perfectly audible and visible to each one of you. Let me know in the chats quickly. Let me know in the chats quickly if I am perfectly audible and visible to each one of you. Come on, my dear lovely students. Good evening, Ruchir. Good evening, Somya Ditya. Good evening, everyone. Good evening. Okay. Now, I believe that we are live now. Before we begin today's session, let me ask you one question. And that question is very simple. Why do so many students work extremely hard in organic chemistry and still they fail to score well in NEET? Not because it is difficult, but because their basics are never taught in the right way. So that's why in this lecture, my dear lovely students, we are going to fix that. Today, I will teach you some basics that many NEET aspirants must know before getting into organic chemistry. So my dear lovely students, come on, mark the attendance. Mark the attendance by smashing the like button. Come on, everyone. Mark the attendance by smashing the like button. Come on, quick. Because this is very mandatory. Liking the session is very mandatory. Come on, everyone. Come on, everyone. Mark this attendance. Come on, quickly. By liking the session. And you can also share this stream with everyone around. Now, should we start today's session? Show some Josh in the chat so that I will start today's session. Come on, show some Josh in the chats. Come on, everyone. Come on, everyone. Show some Josh in the chats so that we will start today's session. Come on. Show some Josh, quick. Some fire emojis, some green hearts. Come on, everyone. Come on, everyone. Come on, everyone. Yeah, that's it. Come on. Yes. Yes. Come on. So without wasting time, let's get started. My dear lovely students, today's topic is basically homologous series. Our topic is actually homologous series. Now the question is, what is meant by homologous series? It's a very basic thing which you should know before getting into what we call organic chemistry. My dear lovely students, homologous series is simply a series, it's simply a group, it's simply a family of organic compounds having same what we call general formula, having same functional group. But remember, my dear lovely students, when functional group is same, that means they have same chemical properties as well. But yes, they can have regular gradation in their physical properties. But my dear lovely students, all members of this family are known as homologs. Now have a look. What is homologous series? Homologous series is defined simply as a family or a group, but of structurally similar organic compounds. All the members of which contain same functional group, same general formula, and hence as functional group is same, hence they show similarity in chemical properties. But yes, they can show gradation in physical properties. That means their characteristic feature of homologous series are: number one, each homologous series can be represented by same general formula. Remember this. That means every homologous series will be having some general formula, and one homologous series is having, one family is having, say one general formula. Yes or no? But this general formula of different homologous series can be same. But remember, my dear lovely students, all the members of a given homologous series, they are known as what we call homologs, and all the members of given homologous series have same functional group. All the members of homologous series are known as homologs. But one homologous series will be having only one functional group. Their general formula can match with other homologous series, but functional group will be only same for all the members of one homologous series. And remember, all the members are known as homologs, and two adjacent members are known as successive members, are known as successive homologs or adjacent homologs. And remember, the difference between two successive homologs is always by CH2. There is a difference of CH2, but we know mass of carbon is 12, mass of hydrogen is 1. So we can simply say two homologs which are successive members, that means two successive homologs, they differ by CH2 group or they differ by 14 mass units. Is this point clear? Now after that, remember, the individual member of homologous series are always called homologs, and the chemical properties of all the members are identical. Why they are similar? Why they are having similar chemical properties? Because because their functional group is same. But my dear lovely students, as we know, homologs differ. Successive homologs differ by means of CH2. That means their molecular mass will be different. Molecular mass is different. That clearly indicates their size will be different, mass will be different, van der Waals forces of attraction will be different. Hence, there will be different what we call physical properties like density, like melting point, like boiling point. I hope this point is clear. Now, let's take one by one different homologous series. But before that, first homologous series is alkane. Can anyone tell me in the chats, what is the another name for alkane? Come on, tell me in the chats. I will be waiting for your response. Alkanes are also known as, tell me. Alkanes are also known as, come on, everyone. I'm waiting for your response. Alkanes are also known as. Very good, Richard. Very good, nice. So, first point you should remember. First point, what you have to remember is that they are also known as paraffins. First point is this one. Because I am going to explain all these points one by one, but with the help of different homologous series. So they are also known as paraffins. Why they are known as paraffins? Now listen carefully. Basically, paraffin comes from two words. One is param. Param means little. And another is affins. Affinis means affinity. Affinity, or you can simply say reactivity. So it's very simple now. Why alkanes are also known as paraffins? Because of their less reactivity or because of their low reactivity. That clearly indicates, this name clearly indicates that alkanes are less reactive, say species. This is point number one, which you have to remember. Point number second, my dear lovely students, is you have to remember their general formula. You have to remember their general formula. Their general formula is CnH2n plus 2. Their general formula is CnH2n plus 2. And you have to remember, we can write down this general formula in this fashion as well. CnH2n plus 1 and H. Or you can also write down this in this fashion, that is capital R and H. That clearly indicates that this CnH2n plus 1 means this capital R. So what is this? N starts from 1 to infinity, my dear lovely students. You have to remember these points as well. First point, they are also known as paraffins. Second point, their general formula. Now, when general formula is in front of you, can you tell me what will be the molecular formula of first member of alkane? When I say first member of alkane, what does that mean? That means I have to put the smallest value of n. What is the smallest value of n? That is 1. So put n equals to 1. In this formula, when you put n equals to 1, it becomes C1. 2 into 1 is 2. 2 plus 2 is 4. That means C1H4. So can I write down it in this fashion directly? That is CH4. That is CH4. Now tell me, is this point clear to you? Now tell me, is this point clear to you? Everyone, tell me quickly. Is this point clear to you? Everyone means everyone. Come on, everyone. Everyone has to answer me. Is this point clear to you? Why they are known as paraffins? Number second, what is their general formula? And what is the molecular formula of first member of alkane? Is this point clear to you? Now, can anyone tell me what will be the molecular formula of its second member? Come on, tell me. What will be the molecular formula of its second member? Come on, tell me, beta. What is the molecular formula of second member of alkane? What will be the molecular formula of second member of alkane? That means second member means I have to put n equals to 2. When n is equal to 2, what will be the molecular formula? Molecular formula will be C2H6. Now tell me, if you remember this general formula, can you tell me at that time the molecular formula of any member of alkane? Say for example, if I ask you what will be the molecular formula of 10th member of alkane? What is the molecular formula of 10th member of alkane? Means you have to put n equals to 2. Now tell me in the chats, what will be the molecular formula of 10th member of alkane? Tell me quickly. What will be the molecular formula of 10th member of alkane? Very good. Richard has given me the answer. What about others? Come on. You have to put n equals to 10. When n is equal to 10, so carbon becomes 10. When n is equal to 10, this hydrogen becomes 2 into 10, means 20. 20 plus 2 is 22. That means it is C10H22. Very good, very good, very good. Nice, Ruchir. At the rate of Mukan, very good. At the rate of Ada, very good. At the rate of Azmina, very good. At the rate of Tinkerly, very good. At the rate of Anna, very good. At the rate of its Somyaditya, very good. At the rate of Afifa, very good. At the rate of Aida, very good. At the rate of small menace, very good. Okay, that's good. That's great. That's great. Now tell me, my dear lovely students, if we talk about, say for example, third member, if we talk about third member, what is the molecular formula of third member of alkane? That means we have to put n equals to 3. Now tell me, put value of n as 3 and tell me what will be the molecular formula. What will be the molecular formula? Come on everyone. It will be simply C3 and H8. Now dear students, look towards these. Can I say these are homologs? Can I say these are homologs? What are homologs? What are homologs, dear students? Homologs mean all the members of a particular series, all the members of a particular family, they are known as homologs. So this is alkane family. It's every member is known as homolog. Is this point clear? Every member here is known as a homolog. Yes or no? But, my dear lovely students, if you look towards this and this, these two are successive homologs. These two are successive members. These two are adjacent members. Now tell me, what is the difference between two adjacent members, two adjacent homologs, two successive homologs? Have a look. This is carbon. This is carbon 2. That means what is the difference? Difference is 1 carbon. Hydrogen 6, hydrogen 4. What is the difference? Difference is CH2. So, the difference between every member, successive homolog is CH2. Yes or no? So they differ. Successive homologs differ by CH2. Or you can say they differ by 14 mass unit. Is this point clear to you? Is this point clear to you? Everyone, tell me everyone quickly. Now, a very simple question. Now tell me, is methane, is this CH4, is CH4 homolog of CH3? Sorry, is CH4 homolog of C3H8? Come on, I want answer in the chats. Come on, quick. Is CH4 homolog of C3H8? Come on, yes or no? Yes or no? Come on. Yes or no? I need answer. Is CH4 homolog of C3H8? Answer is yes. Answer is yes. At the rate of Orochi, answer is yes. Because why answer is yes? Have a look. This is the member of alkane. This is also the member of alkane. All the members of a particular family, particular series, they are known as homologs. But if I talk about like this, is CH4 successive homolog of C3H8? Then answer is no. Then answer is no. So CH4 is homolog of C3H8, but they are not successive homologs. Similarly, is C2H6 and C3H8 successive homolog? Answer is yes. And what is the difference? They differ by CH2 group. Is this point clear to you? Is this point clear to you? So what is meant by a homologous series? It is simply a series, or it's simply a group, or it's simply family of what we call organic compounds. It's a series of organic compounds, or family of organic compounds, or a group of organic compounds having same general formula, having same functional group. Listen carefully. Having same general formula as well as same functional group. They always, that all the members of this family or this homologous series, they are known as homologs. And two adjacent members are known as successive homologs. And successive homologs always differ by means of CH2. Now tell me, they differ by means of CH2. That means they are having different molecular mass. Yes or no? If molecular mass is different, that means their properties, physical properties will be different. But these two differ by CH2. These two differ by CH2. That means the increase in molecular mass between two successive homologs is regular. That's why they show regular gradation in what we call physical properties. Is this point clear to you? Is this point clear to you? But as they have same functional group, that's why their what we call chemical properties will be same. Okay, my dear lovely students. Now, next one is alkene. Alkenes are also known as, my dear lovely students, olefins. Alkenes are also known as olefins. Why they are known as olefins? Remember this name olefin. They got this name olefin because of their earliest members like ethene. When that earliest alkene, ethene, reacts with halogens like chlorine, they form oily liquid compounds. That means they are named, that means alkenes are named as olefins. Only reason is that olefin comes from a word, olefiant means oil forming. They are basically oil forming compounds. They are not oily compounds, but they are oil making compounds. They are oil forming compounds. For example, ethene is a member of alkene. When reacts with halogen, for example, chlorine, when member of alkene reacts with chlorine, it forms oily liquid compound. That means it can form oily compound. So it forms oily compound. It forms, oily compound means it's oil making or oil forming. That's why they are also known as olefins. Now, alkanes are named as paraffins. But alkenes are also named as, they are also known as olefins. This is point number one. Point number second. You have to remember their general formula. Their general formula is CnH2n. Their general formula is CnH2n. And you have to remember that n starts from 2 to infinity. 2 to infinity. Why? Because alkenes must contain or must have, alkenes must have at least one carbon-carbon double bond. They must have at least one carbon-carbon double bond. If alkenes must have at least one carbon-carbon double bond and their general formula is CnH2n, that means alkenes must contain one carbon-carbon double bond, means alkenes must have at least two carbons. If alkenes must have at least two carbons, that's why n starts from 2, n does not start from 1. Is this point clear to you? Now, dear students, can you tell me now what will be the molecular formula of first member of alkene? First member of alkene. What will be the molecular formula of first member of alkene? First member of alkene is now n equals to 2. It's not n equals to 1. It's n equal to 2. Now tell me, when N is equal to 2, what will be the formula? Formula will be simply C2H4. So this is the first member of alkene. Is this point clear to you? Now, what is the molecular formula of second member now? Everyone, let me know in the chats quickly. Second member of alkene. Now tell me, when we talk about second member of alkene, now we have to put N equals to 3. It's not N equals to 2 because first member is having N equal to 2. Second member will be having obviously 1 carbon more. That means N equals to 3. So what will be the molecular formula? Molecular formula will be C3H6. Very good, very good, very good. Great. Everyone is giving me the right answer. God bless you all. God bless you all. Everyone is giving me the right answer. God bless you all, beta. Now, can anyone tell me what will be the molecular formula of third member? Quick, quick. Let me see who among you will give me the right answer first. What will be the molecular formula of third member now? What will be the molecular formula of third member? Ruchir has given me the right answer. Somya Ditya, very good. Orochi, at the rate of nostalgia. Great. At the rate of Anna. At the rate of Sinchan. Areva. At the rate of Safa. At the rate of Ahmed. At the rate of Siddharth. At the rate of Sahiba, very good. At the rate of Mukand, at the rate of Tinker, at the rate of Sheikh Wakas, at the rate of Kafwani, very good. At the rate of Yesh, at the rate of Azmina, at the rate of Afifa, at the rate of Safa, very good, very good. At the rate of Haritha, nice. At the rate of Mir Arisa, at the rate of Ada, at the rate of Aida, at the rate of Muhammad. That's great, that's great, that's great. Now, because whenever we give value of N, you have to be very much careful about the value of N, because in case of alkane, first member was having value N equals to 1. But in case of alkene, it is N equals to 2 first member. So second will be N equal to 3. Third member will be once again N equal to 4. So you have to be very much careful about the value of N. So N is equal to 4, which clearly indicates this becomes C4H8. It becomes C4H8. It becomes C4H8. I hope this point is clear to you. Now tell me, beta. Now tell me. If I talk about this one, can I say this is the homologue of this? As well as this is the homologue of this one. Or we can say all these three are homologues. Yes or no? All these are homologues. Yes or no? Come on, tell me. All these are homologues. Yes or no? But can I say this and this are successive homologues? These two are successive homologues. But first and third, they are not successive homologues. And if you look towards successive homologues, what is the difference? Difference is CH2. That means they differ by CH2 or they differ by 14 mass units. I hope this point is clear. After that, my dear lovely students, there is another, that is alkyne. And remember, general formula for alkyne is simply CnH2n minus 2. And here n once again starts from 2 to infinity. Why, sir? Why 2? Why not 1? Once again, simple reason, and that simple reason is that alkynes must contain at least one carbon-carbon triple bond. Now, can you tell me now what is the molecular formula of first member? That means the simplest value of N should be equals to 2. So when N is equal to 2, what will be the formula now? It is C2H4 minus 2. That means it is C2H2. Now, what will be the molecular formula of second member now? Come on, everyone. Molecular formula of second member will be N equals to 3. That means becomes C3 and then H4. It becomes C3, this becomes H6 minus 2, that means H4. Similarly, dear students, what will be the molecular formula of third member, dear students? What will be the molecular formula of third member? That means N equals to 4. Now listen, If you are talking about 3, you have to give value n equals to 4. That means you have to add 1. 1, 2, 2, 3, 3, 4. That means you have to add 1 to get the value of n. So what will be the formula? Formula becomes C4 and then H6. Is this point clear to you? Now, can anyone tell me what will be the molecular formula of 20th member? What will be the molecular formula of 20th member of alkyne? Tell me. What will be the molecular formula of 20th member of alkyne? Can anyone tell me? Can anyone tell me among you? Come on, tell me. What will be the molecular formula of 20th member of alkyne? 20th. I am saying 20th member of alkyne. Very good. Very good. God bless you. God bless you. At the rate of Mukand. No, this is wrong, Mukand. Because when we talk about 20th member, that means your value of n should not be 20. Because have a look, first member is not having 1 value. First member is having 2 value. And third member is having 4 value. That means you have to add 1. When I say 20th member, your n should be 21. Your n should be 21. Your n should be 21. Varshini, it's not 28, it should be 21. Others are correct. So, when we talk about, listen carefully, when we talk about first member, value of n is 2. Value of n is not 1 here. So, it's 1, here it should be 2. Here it is 2, here it should be 3. That means, have a look, you have to add from this position to this position, you have to add 1. So, if I talk about 20th member, that means n value should be 21. So when n is 21, so this is 21, this becomes 42 minus 2, that means 40, that means C21, H40. C21, H40. Is this clear to you? Now let me know in the chats. Am I clear till now? Let me know in the chats quickly. Am I clear till now? Let me know in the chats quickly. Am I clear till now? Everyone, come on everyone, respond everyone quickly. That's great. God bless you all. God bless you all. Now, after this, I have written over here alkadiene. What is meant by ene? Means carbon-carbon double bond. What is meant by diene? Means there must be 2 double bonds. So, let me write down over here. Alkadiene, that means these compounds must contain 2, I mean to say double bonds, or 2 carbon-carbon double bonds. Must contain 2 double bonds. And what will be their general formula? What will be their general formula? What will be their general formula? Their general formula will be CnH2n minus 2. Now, my dear lovely students, have a look towards general formula. This general formula is similar. This general formula is similar as that of alkynes. General formula is similar, but functional group is not similar. Here, general formula is CnH2n minus 2. Here, general formula is also CnH2n minus 2. Now, listen carefully. Tell me, how many carbons must be present in the simplest member so that we can show 2 carbon-carbon double bonds? Now tell me, for at least 2 carbon-carbon double bonds, the minimum number of carbons should be how much? Can anyone tell me? Can anyone tell me? Oh, wow, that's great. That's great. Minimum number of carbons must be how many? Now have a look. Can I say this is carbon-carbon double bond? But this is only 1 carbon-carbon double bond. We have to form how many? We have to form 2 carbon-carbon double bonds. So I have to form 1 more carbon-carbon double bond. That means there should be minimum, at least there should be 3 carbons. Yes or no? So can I write down over here? That means if number of carbons are at least 3, so what is the value of n? Because n means number of carbons over here. So can I say n starts from 3 to infinity? N starts from 3 to infinity. Is this point clear to you? Is this point clear to you, beta? Is this point clear to you? Everyone, please let me know in the chats. Is this point clear to you? Is this point clear to you? That's great. That's great. That's great. Now, come on. Let's try to find out the molecular formula. Come on. Molecular formula first member. Molecular formula first member. But you have to remember, first member does not always mean that n is equal to 1. Remember this one. Sometimes it may be, first member may be n is equal to 1. But sometimes n is equal to 0. But sometimes n is equal to 2. And in this case, n is equal to 3. Now, you have to check what? Have a look. You have to check this one. This is 1. First member means 1. Now, when your first member is there, your n value is 3. Now tell me, it's not same. Value is not same. 1, 3. That means you have to add 2. You have to add 2 to this number to get what we call your n value. Is this point clear to you? Is this point clear to you, beta? Now tell me, my dear lovely students. Now tell me, lovely students. If value of n is 3, put this value in this one, in this general formula. Can I say it becomes C3? It becomes 2 into 3 is 6. 6 minus 2 is 4. Now tell me what will be the formula. Formula is C3H4. Formula is C3H4. Is this point clear to you? Now, can anyone tell me what will be the molecular formula of second member? Molecular formula of second member. What will be the molecular formula of second member? Which value I have to put for, say this n? Come on, tell me. What will be the molecular formula of, say second member? What should be the value of n for second member? What should be the value of n? Have a look. You have to add 2. So, this is 1. Add 2, it becomes 3. For second member, this is 2. So, add 2, n value becomes 4. Yes or no? Very good. Very good. Very good. God bless you. So, you have to put value of n as 4. Now, put this value over here. So, it becomes C4. 2 into 4 is 8. 8 minus 2 is 6. So, it is C4H6. Now, you can randomly check 2 successive members. These are 2 successive members. Have a look. Carbon 4, carbon 3. So, their difference is 1. Hydrogen 6, hydrogen 4. Difference is H2. So, difference between 2 successive homologues is always CH2. Now, what will be the molecular formula of third member? Come on, tell me. Molecular formula of third member. Come on, everyone. Molecular formula of third member will be. Now, third member. Third member does not mean n is equal to 3 here. Third member means n is equal to 5 here. N is equal to 5. So, this is 3. Add 2. You will get value of n. Now, give this value in this one. Tell me, what will be the formula? C5. 2 into 5 is 10. 10 minus 2 is 8. That means it is C5 and H8. So, have a look. Difference is once again CH2. You can add CH2, you can directly form this one as well. But first of all, you should know what is general formula and what is the simplest value of what we call n. Now, how many among you can tell me if I want molecular formula for 9th member? What will be the molecular formula for 9th member? Come on, tell me. What will be the molecular formula for 9th member? Come on, everyone. Tell me. Because when I say that molecular formula of 9th member, what will be the value of n over here? Come on, everyone. Tell me. Come on, everyone. Very good. Very good. Siddharth. Very good. Nice, beta. God bless you, Siddharth. Very good. Very good. When I say 9th member means n should be. You have to add 2 to 9. Add 2 to 9. That means it becomes 11. So, n will be 11 at that time. So, put n as 11. So, it becomes C11. It becomes H22 minus 2. That means C11 H20 will be the right answer. Very good. Very good. Very good. God bless you. 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 Now, my dear lovely students, after this alkadiene, there is one more, and that is alkatriene. That is alkatriene. Now, have a look. Their general formula is, dear students, first of all, let me tell you that these compounds must contain what? Now, you can easily tell me now. Triene means these compounds must contain 3 carbon-carbon double bonds. Yes or no? must contain at least 3 carbon-carbon double bonds. Now, dear students, second thing is that you should remember their general formula. You should know what is the general formula of such compounds. Now tell me, general formula of such compounds will be CnH2n minus 4. CnH2n minus 4. Can anyone tell me? For 3 carbon-carbon double bonds, how many minimum number of carbons should be there? How many minimum number of carbons should be there? Come on, everyone. 3 carbon-carbon double bonds. You have to form 3 carbon-carbon double bonds. These are 2 carbon-carbon double bonds. Now, at least 3 carbon-carbon double bond. For 3 carbon-carbon double bond, come on, tell me, what should be the, say, minimum number of carbons present? What should be the minimum number of carbons present over here? It should be 4. So, if it is 4, can I put value of n here as 4 to infinity? Can I say it's 4 to infinity? Yes or no? Yes or no, beta? Now. Can anyone tell me what will be the molecular formula of first member? Come on, quick. What will be the molecular formula of first member over here? Molecular formula of first member. Can anyone tell me? Molecular formula of first member means N is equal to 1? No. N is equal to 2? No. N is equal to 3? No. Then N is equal to 4. Minimum value is N equals to 4. So when N is equal to 4, can anyone tell me what will be the molecular formula of this? It will be C4H8 minus 4. That means it becomes C4H4. C4H4. Now, what will be the molecular formula of second member? Come on, quick. Be quick and tell me the answer. Second member. But you have to think only this thing. You have to remember this thing only, that for 1, answer is 4. So you have to add 3 to 1 so that it becomes 4. Now add 3 to second, it becomes 5. So you have to add 3 to 1, 2, 3, 4 so that you will get the value of N. Now tell me, N is 5. So it becomes C5H6. It's 10 minus 4 means 6. Now what is the molecular formula of third member now? Molecular formula of third member. Come on, quick. Tell me. N is equal to 6 now. Because this is 3. Add 3. You have to add 3 when alkatriene is there. So, formula becomes C6H8. If you look randomly towards successive homologues, difference will be always CH2. Difference will be always CH2. Now, who among you can tell me what is the molecular formula for seventh member? Come on, tell me. Molecular formula for seventh member. Come on, quick. Molecular formula for seventh member. Who can tell me the molecular formula for seventh member? Who can tell me the molecular formula of seventh member? Come on, quick. Very good. Very good. Great. Great. Happy for you. God bless you all. God bless you all. Yes, seventh member. You are writing C5. C5 is this one, beta. Second one. You have to write down seventh member. Seventh member, beta. At the rate of Safa, you have to write down seventh member, beta. Come on, seventh member. When I say, have a look. When I say first member, value of N is 4. That means you have to add 3 to this. Similarly, add 3 to this. N becomes 5. Add 3 to this 3. So N becomes 6. Now, I am saying seventh member. You have to add 3 to this. That means N becomes 10. When N becomes 10, so it becomes C10. H20 minus 4 means H16. So that is C10, H16. That is C10, H16. Is this point clear? Now, another thing is alkyne. That means alkane. Alkane. En is there, yne is also there. That means, remember, these compounds must contain. These compounds must contain at least one carbon-carbon double bond and one carbon-carbon triple bond. Now, if these contain at least one carbon-carbon double bond and one carbon-carbon triple bond, remember beta, their general formula is once again same, CnH2n minus 4 as that of what we call alkatriene. Now the question is, can anyone tell me how many carbons should be there at least so that there should be one carbon-carbon double bond and there should be one carbon-carbon triple bond? How many carbons must be present in that compound at least? Tell me the number of carbons present in a compound at least which contains one carbon-carbon double bond and one carbon-carbon triple bond. Now have a look. If I write like this is carbon-carbon double bond. Can I write down it in this fashion, carbon-carbon triple bond as well? Can I write like this? Can we write like this? Tell me. This is carbon-carbon double bond, this is one carbon-carbon triple bond. But we cannot write like this because this carbon becomes pentavalent, which is not possible. It becomes pentavalent, which is not possible because it forms 1, 2, 3, 4, 5 bonds. It's not possible. That's why, my dear lovely students, we have to think on these lines. Say, for example, this is carbon-carbon double bond. Then this is carbon-carbon triple bond. That means at least such compound must contain at least 4 carbon atoms. So the simplest alkene must contain beta n equals to 4 to infinity. Now tell me, dear students, if I write down like this, if I say, what is the molecular formula? What is the molecular formula of first member? Come on, tell me. First member means n equals to 4. N equals to 4 means once again C4 and H4. Now, what is the molecular formula of second member, my dear lovely students? What is the molecular formula of second member? Molecular formula of second member means n is equal to 5. Once again, formula becomes C5 and then H6. Difference will be always CH2. And what is the molecular formula of third member? Can anyone tell me? Third member does not mean n equals to 3. Third member here means n is equal to 6. So it becomes C6 and H8. So what is the difference? Difference is CH2. Now tell me, is this point clear to you? Is this point clear to you, beta? Is this point clear to you, beta? Now have a look now. If I write down like this, C double bond C double bond C, then here it is H2, it's H2. What is this? This is alkadiene. Now if I remove this one and if I write down in this fashion, what is the molecular formula of this? What is the molecular formula of this? Have a look. 1, 2, 3, 4 carbons are there. So it is C4. How many hydrogens are there? 2 and 2, 4 hydrogens are there. So this is C4H4. Yes or no? Now, if I write down like this, CH2 double bond C, single bond C, triple bond C, single bond H. If I write down like this, have a look. 2, 3 and 4. 4 carbons and 4 hydrogens are there. Both are having, have a look, both are having same general formula. What was that? CnH2n minus, say 4. General formula for this compound and this compound are same. But tell me, are they same compounds? No. This is triene, this is alkene, this is alkatriene, this is alkene. So remember, these are different compounds. When different compounds are there, when compounds belonging to different homologous series are there, but they are having same molecular formula, remember they are always functional isomers of each other. They are always functional isomers of each other. They are always functional isomers of each other because they belong to different homologous series. When members of different homologous series are there, they are having different functional group. This is having functional group, one functional group, this is having another functional group. They are having different functional groups. Different functional groups having same molecular formula. So we can simply say they are isomers, or simply they are known as functional isomers. I hope this point is clear to you. Is this point clear to you, beta? Is this point clear to you, beta? Is this point clear to you, beta? Now Now, let's take once again alkane. Let's take once again an alkane. Now listen carefully. Let's take once again an alkane. Can anyone tell me once again what was the general formula for alkane? Yes, you can tell me now easily. CnH2n plus 2. Yes or no? What is the value of n? I mean, say the simplest value of n starts from 1 to infinity. Simplest value of n starts from 1 to infinity. So this is the general formula. Now dear students, listen carefully. We know when we talk about molecular formula of first member, that means we have to put n equals to 1. That means at that time molecular formula will be CH4. Similarly, when we talk about molecular formula of second member, have a look. I'm basically going to show something. N is equal to 2. At that time molecular formula becomes C2H6. Yes or no? When we talk about molecular formula of third member, we know at that time N is equal to 3 and molecular formula becomes C3H8. Similarly, dear students, when we talk about molecular formula of fourth member, dear students, we know at that time N is equal to 4, which means formula becomes C4H10. Similarly, dear students, when we talk about fifth member, what is the molecular formula, dear student? Molecular formula of alkane at that time will be C5H12. Now listen carefully now. Now tell me, what is the simplest value of n? Simplest value of n is 1. What does that mean? Have a look. When we talk about that simplest value of n is 1 carbon. That means simplest value of n is 1. That means our alkane must contain at least 1 carbon. Now listen. When alkane contains only 1 carbon and molecular formula is also CH4, have a look towards this alkane. Look towards this alkane. If you look towards this alkane, beta, you can have look towards this alkane. When you look towards this alkane contains 1 carbon. If alkane contains only 1 carbon, have a look. We have written that. Now try to satisfy the valency of carbon. Carbon can form how many bonds? Carbon is tetravalent, tetracovalent. That means try to satisfy the valency by adding hydrogen. That means you have to add now what we call hydrogens to it. So this will become CH4. Now listen carefully. Simplest unit is carbon. But suppose our molecular formula of alkane is C2H6. Molecular formula is C2H6. This is the simplest unit. Now, what you have to do is, formula is C2H6. Now listen carefully. Formula first was CH4, so you write down directly. Now formula is C2H6. Now what you have to do is, you have to write down first of all simplest unit. And what is that? That is 1 carbon unit. Now how many carbons are there? 2. Now what will we do? I will form one more bond with this. I will add one more carbon with this. Is this point clear to you? Now, what is the molecular formula? C2. C2 is there. Now you have to satisfy the valency. Put 3 hydrogens to it. So this is the structure of this. Now, if we talk about C3H8, tell me, simplest unit is carbon. Now, how many carbons are in our molecular formula? 3. But we have only 1 carbon in simplest unit. Now you have to add 2 more by like this, by forming bond, either from right side or from left side or from top or from bottom. It's up to you. Now form 3. Add 2 more carbons to this carbon, to this structural unit. To this fundamental unit, to this smallest unit, you have to add 2 more carbons because formula is C3. Now after this, you have to add hydrogens so that valency of every carbon is satisfied. So this is the structure of this one. Now tell me, how many structures are possible for methane? Only one is possible for methane. Only one structure is possible for methane. How many structures are possible for this CH3 known as ethane? Only one is possible for this. How many structures are possible for C3H8? Only one is possible for C3H8 as well. Now listen carefully, beta. If I write down C4H10 now, C4H10. Now do you know, beta? We have simplest unit, this carbon. But how many carbons are there in this? We have 4. This is the simplest unit. Now how many carbons we have to add now? We have to add 3 more carbons. So 1, 2 and 3. Is this point clear to you? Now, once again, this is the simplest unit. Here I have added 3 carbons. Now I will do this thing. I will add only 2 carbons in a chain, and third carbon will be in the form of a branch. Third carbon will be in the form of a branch. Either you have to add 3 carbons in a straight line, or you have to add 3 carbons in such a way so that overall there will be a branch. Now the question is, this type of alkane is known as straight chain alkane. This type of alkane is known as branched chain alkane. Which type of alkane is branched chain alkane? In which at least 1 carbon is bonded to 3 or more carbon atoms. Look towards this. This is attached to 3 carbon atoms. So this is a branched chain alkane. But that alkane in which maximum 1 carbon is attached maximum to 2 carbons. Have a look. This is maximum attached to 2 carbons. This is only 1 carbon is attached to this. So maximum this carbon is attached to 2 carbons. This carbon is attached to 2 carbons in maximum. So when we add hydrogens to it, you will simply say there are 2 possibilities of this formula. There are 2 possibilities of this formula known as C4H10. Is this point clear to you, beta? So you have to remember basic unit, and after that you have to add carbons so that you can find out easily how many possible structures are there. So C4H10 is having how many structures possible, beta? It's having 2 structures possible. 1, you have to fix carbon. After that, 3 carbons in a chain. 1 fix, then 3 carbons in such a way that at overall there should be 1 branch. I hope this point is clear. After that, beta, haloalkane is there. Haloalkane is also known as alkyl halide. Haloalkanes are also known as alkyl halides. Alkyl halides. Haloalkanes or alkyl halides. Remember, beta, forever that their general formula is CN H2N plus 1 and X. Here, what is this value of N? Once again, value of N starts from 1 to infinity. What is X? X is halogen. It can be fluorine, chlorine, bromine, iodine. It can be anything. So this is the general formula, beta. Now, can you tell me now, what will be the molecular formula? What will be the molecular formula of first member? What will be the molecular formula of first member? That means N equals to 1. Similarly, what will be the molecular formula of second member? That means N is equal to 2. And dear students, what is the molecular formula of third member? Which means N is equal to 3. So what will be the molecular formula over here? So put value of N as 1. So it becomes CH3X. What about this? It becomes C2H5X. What about this? It becomes C3H7X. Look towards this, beta. Look towards this. They always differ by CH2. So homologs differ by CH2. I hope this point is clear to each and every one there. Let me know in the chats quickly, is this point clear to each and every one? Is this point clear to each and every one? Let me know in the chats quickly. And let me tell you that if you are really serious about securing top score in NEET 2027, my dear lovely students, then remember forever, you need more than just random, videos. You need a very well maintained or structured plan. You need proper guidance, and that too from experts, expert guidance. You need expert guidance. You need consistent practice, beta, and you need accountability. And that's exactly, we have launched what we call Phoenix 3.0 batch, beta, on Unacademy. It's a complete NEET batch for students who basically want to clear their concepts deeply, who basically wants to practice consistently, who basically wants to be consistent till the final exam, my dear lovely students. If you are among those students, then let me tell you, this is the perfect place to join in. So that's why I want to tell you that you can join our team, beta. Here you have Yavar sir for physics, you have biology, you have Tina ma'am for complete biology, and you have 3 teachers for different branches of chemistry. For inorganic chemistry, you have Sonali ma'am. For physical chemistry, you have Wasim sir. And for organic chemistry, I will be taking care of that organic chemistry, my dear lovely students. It's not only that you will get benefited over here, not only that you will get benefited by us, but there are top-notch teachers as well, beta. You can learn from India's top educators. There are 1, 2, 3, 4, 5, 6, 7, 8 chemistry teachers are there. And you can have a look. There are 17 teachers in total, from which you can have an access from these all teachers, my dear lovely students. And you can have access of all batches. You can have access of all batches, and that only at 4499. Beta, if you have not enrolled yet, enroll quickly, because link is in the description below, beta. Click that link and enroll right now. Enroll right now. And one more thing I want to discuss with you. As you know that your NEET exam 2027 is going to be held in what we call CBT mode, beta. That's why CBT is very, very, very important now. And Unacademy has already started your mock test series, CBT mock test series, and you can join either online or you can join as offline as well. And the price is very less. It's only 2999 online. 28 online proctor tests will be there, and 15 online proctor tests plus 13 offline proctor tests will be there. Computer based tests will be there at a rate of 5,999. And one more thing, beta, that on this 2nd August you have free CBT test. So don't waste your time. If you have not enrolled, if you have not joined this, enroll for this CBT test, you can have a link in the description. Click that link, enroll as soon as possible. One for this CBT, another for Phoenix 3.0, because we are going to teach you from very scratch there and to advanced level. And anyways, thank you very much. God bless you all. This is all about today's session, my dear lovely students. This is all about today's session. So I want to thank you all. God bless you, and don't forget to join as soon as possible in Phoenix 3.0, as well as, my dear lovely students, in what we call CBT mode, because that exam is very, very important. You should know how to basically use this computer, because you should be very much, you should practice this CBT test very much. Now, I hope everything is clear. Everything is clear, beta, till now. Now, let's discuss other things in your batches. Will discuss everything from very scratch to advanced level. We will discuss organic chemistry in such a way that no question in your NEET 2027 can bother you. So anyways, thank you and God bless you all. But I would want you all guys, once I end this session, I would want comments from all the students, from all my future doctors, that how much do you like this session and where from you are watching this session. So take care, bye bye, and God bless you all. But I will be waiting for your